what if I have x to 2/3? I am given f prime as being x to 2/3. I'm asked to find f of x plus c, which is the most general antiderivative. No problem. In order to find f of x, I increase the power by 1. I divide by exactly the same number, and I put plus a constant c. 2/3 plus 1, so this will be x to 5/3. I don't have to calculate it again, it's the same number, 5/3 plus a constant c, but I have to flip. 3/5 x to 5/3 plus a constant c. What does this represent? The most general antiderivative of this function. Infinitely many functions, because I can have any c, any constant, anything. So for that reason, infinitely many functions have the same derivative. Now, if I am given a point, let's say for this function 0, 1. Is this a point of this function? Yes. When x is 0, 0, 0. When x is 0, y is 0. So, can I determine a specific c? Yes. If I am given a point or a condition, we call it initial condition. Then I can determine the exact or unique function, because c will be 0. So if I'm given a point, I can determine a unique function. If I'm not given a point, then I will determine the most general antiderivative. I want us to work on a few problems, and then I'm going to show you a notation of this. They're not giving us, okay, yes, they are giving us. So page 392. I may have been logged out. It's not impossible. No, I'm not logged out. I'm not even logged in. Oh, here it is. I am logged in. No, I'm not logged in. I meant to. Okay, fine now. Here is, okay, I was in the middle of it. So yes, I'm logged out. Thank you very much. So I have to start from scratch. I have to close this. Let's see. And we want page 392. Okay, from 47 through 56, find f. We are given a derivative, we are going backwards to find the function. Before you choose e to the x, I have to explain a little bit more. Let's choose a polynomial function, and then we'll look at something like this and something with e. So first let's start with 47 through 52. If you don't choose, I will. Okay. So we have, I'm on page 5. So we want to 52, you said. So f prime of x equals 6x squared minus 4x plus 2. And we are given f of 1 is 9. Perfect. So they're asking us to find a unique. We are given an initial condition. In other words, when x is 1, y is 9. So 1 comma 9. Good. So then, to find f of x, I keep 6 alone. Which function prime is x squared? Can anyone figure out which function prime, which function I differentiate to get x squared? So we are going backwards. I have to increase the power by 1 and divide by that number. Anyone?
It would be 2x cubed.
X to the third divided by 3. So when I differentiate this, I bring down 3, I subtract 1 from the power, and the 3 goes away, and I get back x squared. Is that okay? Is that okay? Say it again. Sure. I increase the power by 1, and I divide by this number. I increase the power by 1, and I divide by exactly the same number. So,
how come the constant isn't, like the 6, how come that doesn't change?
so let's differentiate this piece and see if we get 6x squared.
Okay.
So I have 6x to the third divided by 3 prime. I have 6 times 3x squared divided by 3, and I get 6x squared. Is that better? Is that okay?
Is that going to be the case? We just keep the number the same?
We always do, even when we differentiate, right? So if I'm asked to differentiate 7x to the third, I don't do anything to 7. It happens that I have to multiply it by 3, but I don't touch 7. Nothing happens to 7. Unfortunately, I have to multiply it by 3, so it's 21x squared. But 7 is still in there. Nobody touched this. The same thing here. Nobody touches the constant in front. It will simplify eventually with something, but we only copy this. I only copied 7, but I had no choice but multiply it by 3 to get 21. But nobody touches the 6 and nobody touches the 7. Is that better? Yes? Questions? Is this okay?
Yes.
Perfect. So I copy -4, which function prime is x.
X squared
Not good enough?
over x.
Not good.
Over 2.
Exactly. Plus, which function prime is 2?
X.
You mean we copy 2 and x plus a constant c. Why do I need a constant? It's because all these functions have the same derivative. This prime is this prime is this prime is this, c prime is 0. I have to clean this up because I can. So I have f of x equals 2x to the third minus 2x squared plus 2x plus c. Is this okay? 6 divided by 3 is 2, 4 divided by 2 is 2, 2x plus c. Now, I will use this point. When x is 1, y is 9. Why do you think the point is given to us? In order for us to determine what?
The constant.
Exactly. So this will be no longer an infinitely many functions, but just one. So 9 equals 2 minus 2 plus 2 plus c. C is 9 minus 2. So c equals 7. So the function whose derivative is this and passes through this point is only 1. is this function. 2x cubed minus 2x squared plus 2x plus 7. This is the only function whose derivative is given to us, and also when f is 1, y is 9. 2 plus 7 is 9. This is the only one. So this is no longer the most general antiderivative of this function. No, it's just one function whose derivative is that, but also passes to the point 1, 9. Good. Now let's practice something with e and then something like this in a moment. But let me explain e first. Any questions on this problem before we look at e? Okay, so e is, that's my page 6. E is a similar situation. So if I have f prime of x equals e to the x, can anyone give us the function, the most general antiderivative, the function whose derivative is e to the x? But I want first the most general antiderivative. It's okay if you're wrong. Just try, please.
Would e to the x equal e to the x plus 1 over n plus 1? I mean e plus 1. No.
So the most general antiderivative is this function, because e to the x prime is e to the x and constant prime is 0. But from here we want to build on something else. What if we have f prime of x equals e to 3x? Or any number. But for now, let's just say 3, and then we'll choose a different number. It doesn't matter. Can anyone now help with f of x? These are not the same. So I have to be careful. So which function prime, when I differentiate it, I get e to 3x? And which function prime? Yes, I'm sorry. Go ahead.
I was going to say, would it be e to 3x plus 3x over 3x?
But the derivative of 3x is not 3x, right? It's just 3, right?
That's true.
Plus a constant c. So now let's differentiate. E to 3x prime is e to 3x times 3. The 3 goes away. And I get e to 3x. And the derivative of the constant is 0. Okay, what if I have f prime of x equals e to 7x? Can anyone give us the antiderivative, the most general antiderivative of e to 7x?
By 7
Plus a constant. That's it. Excellent. Good. So let's choose one with e to the x. Let's do 53 this time. And let's see what we get with 53. Well, we have, they are given us f prime of x, 5e to 2x, and they are giving us an initial condition. F of 0 equals 1/2. Which means this is a point. What point? The point x equals 0, y equals 1/2. But first I have to find the most general antiderivative of this function. And again, don't be thrown away by 5. 5 stays. There is nothing we can do with a constant in front, no matter what. If it's a derivative and if it's something else, it doesn't matter. 5 is 5. But we need the antiderivative, in other words, which function we differentiate to get e to 2x.
So would it be e to the 2x divided by 2?
Absolutely, plus a constant c. That's it. Now I have to plug in this point in order to find c, and then I'm done. And this is just simple algebra. So I'm on page 7. So I plug in. So, page 7. So, let's plug in 0. 5/2 e to 0 plus a constant c equals 1/2. Can anyone tell us how much is e to 0? Is anyone with me? I know everyone knows what e to 0 is.
0.
Any number raised to 0 is 1, except 0 raised to 0. So 0 raised to 0 is not 1. Other than that, any constant raised to 0 is 1. So 1/2 minus 5/2 equals c. And this is -4/2, which is -2, so this is it. I put it back in the function. So then I have f of x equals 5/2 e to 2x minus 2. This is the unique function whose derivative is this, and when x is 0, y is 1/2. There is only one function with that derivative and passing through 0, 1/2. Okay, one more, and then we're going to look at a fancy symbol. Okay, let's also look at 4 over the square root of x. So that's 55. F prime of x equals 4 over the square root of x, and they're giving us f of 1 equals -5. In other words, they're telling us when x is 1, y is -5. Good. How would you change this to make it easier to work with? How will you change that? Even if you want to differentiate, we're not differentiating, but even if you differentiate, how will you change it?
The x to the 1/2.
Yes, but you mean 4 times x to -1/2, indeed. So the square root of x is indeed x to 1/2, but since it's in a denominator and I want it up, I'm going to have to write -1/2. Awesome, great job. This is easier to differentiate, and it's easier to what we're doing right now, So can anyone help with f of x? 4 has to stay. Nobody can touch that. So now I need to figure out which function I differentiate to get this. And yes, of course, I would have to put a c. Why? Because c prime is 0. And that's what I have here. I don't see it, but it's 0.